Alright, so hi everyone. In this video, we are going to see this question average gift. Let's read it. Chef has a set containing the n distinct integers. Chef want to give the chef an array A of any finite length such that the following conditions hold true. Like the AI belongs to S. For all the I in the other words, each element of the array A should belong to set S. Mean value of all the elements in the array A is exactly X. Find whether there exists an array of the finite length satisfy the above condition or not. Basically, we have an array of S of length n having the n distinct elements, and we want to find that whether there exists a new array A having the value or elements from that particular original parent array S such that all the mean value of the elements of array A is exactly X. Sorry. Okay. So these are the constraint that the Si is not equal to Sj for all the i's not equal to j. This basically defines that the elements in the S array are distinct or not. So these are the input test case and output. Okay. Now to solve this particular question, if you clearly observe that, okay, let me show you. Now, if you clearly observe that, let's say we have an array having element as a0, a1, a2, a3 up to so on. Now, once I sort these elements, let's say these all the elements of an array. This a is not an array. This a3 is an element of the original array S. Okay, plus means these are from the S set, plus all these elements are sorted. Assume that all these elements are sorted. Now, if the x, if the x I want to produce, or the x mean which I want from my original S set, now, if this particular x is small than the first element itself, which means all the elements of the array S are greater than x, right? The x value is small than the a0 defines that all the rest of the elements are greater than the x, which clearly indicates a no. No means that it is not possible to find any subsequence, or we can say that any subpart of the original array S such that the mean of that particular subpart is x. So we print no. Similarly, if you observe carefully, if our particular x is greater than that a of last element a of n suppose, then also we print no. Now why? When the x is greater than n, which means all the elements here are less than, right? And then we are taking mean, so the mean is always is less than the highest element. Like say you take the mean of the first 10 numbers, then the mean is already 5 to 6, right? It is not 12, 13, right? So if x is greater than the a of n, then also we print no. In all the other cases, there exists a way so that we can get an array x, right? So in all the other cases, we print up yes. The basic idea is you need to understand why when the x is smaller than the a0 the answer is no, and why when the x is greater than a of n the answer is no, because the otherwise case is easy. You can take any two array elements such that the x should belong to the a naught to a n range, then there always exists a simple array such that their mean is x. There always exists. You can check. You can verify that. So based on these premises, let's code it. First of all, I have defined t. Taking the input, t defines the number of means the test cases, then iterating over the tree t. Then I have defined two variables n and x. Taking the input, initializing an array, right? Take the input into the array, sort the array. Sort is this is the basically means the inbuilt function used in the C++ to sort a particular array of size n. Now we are checking if the x is greater than the array of n minus 1 because the indexing is 0 base, or the x is less than a of 0. Here instead of or we can also put this one, we output no, otherwise we output yes. So let's submit it and see. Submit it. So this is the code for the problem average gift. It basically says if the in the whole array S, if the initial element is small than the x, sorry, if the initial element is means greater than x, then no. If the last element is also means less than x, then also no. Otherwise, we print yes. So this is the code for the problem average gift. Hope you all liked it. Thank you.